So you probably have your own way of factoring, which is great. I want to go through with you my way of factoring as a review for you, and also maybe a better way, because I know that often when people are factoring, they're just guessing and checking, and we're not going to do any of that, okay? So when we go through the instructions here, they're going to sound crazy. Just bear with me. Once we've done one or two, it'll make more sense, okay? So first, when I do not have a lead coefficient, so I just have a plain quadratic. When I factor, I have two sets of parentheses, and I put an x in each set. The sign in the first set of parentheses is the same as the first sign in the problem. So whatever this sign is goes right here. This is how we avoid too much guess and check, okay? We're going to put the signs in first, and then we're not going to have to worry about it. The sign in the first set times the sign in the second set has to give you the last sign. And then we look for two numbers that will multiply to give us that constant value, and use the last sign to give us the value of the linear coefficient. We ignore the signs at that point because we've already put them in our parentheses. When we put those two numbers in, we always put the bigger number in the first set and the smaller number in the second set. So we're going to go through and do a few and just be sure that you're with me here. Again, I know the instructions look kind of crazy, but once we've done it, you'll be like, oh, okay, this makes sense. If you have another way to factor that you get right every single time, then by all means use that. But if it's been a little bit, try mine. So looking at this first one, y squared plus 8y minus 33. So we would do two sets of parentheses with a y in each set. The sign in the first set is positive because that's the first sign in the problem. The sign in the second set is negative because positive times negative is negative. Then I'm looking for two numbers that will multiply to give me 33 and subtract to give me 8. So 11 and 3, right? And I put the 11 in the first set. So the way this is different is a lot of people, when they factor, would say, okay, multiplies to give me negative 33, right, and adds to give me positive 8. So this way, if we put our signs in our parentheses already, we're not worried about the sign, S-I-G-N, of that last thing, right? We've already taken care of it. Looking at the one next to it, I'm going to have two sets of parentheses with a y in each set. The sign in the first set is positive because the first sign is positive. The sign in the second set is negative. So now I'm looking for two numbers that will multiply to give me 15 and subtract to give me 2. 5 and 3 with the 5 in the first set. Looking at the third one, two sets of parentheses with an x in each set. Sign in the first set is negative. Sign in the second set is negative, right? Because negative times negative is positive. And I'm looking for two numbers that will multiply to give me 4 and add to give me 5. 4 and 1. Are you okay? Making sense? Easy enough? Let's do one or two more. So, two sets of parentheses with an x in each set. Sign in the first set is positive, right? Sign in the second set is negative, because positive times negative is negative. And I'm looking for two numbers that will multiply to give me 16 and subtract to give me 6. 8 and 2. Makes sense, right? So that's how it works if we do not have a lead coefficient. Okay? And again, you might have your own way, and that's great. But if you don't, try this. Now I want to look at what happens if we do have a lead coefficient. This is typically called the AC method, or it's kind of like a little part of the AC method combined with what we just did, okay? So we're going to do the same thing we just did, but we're going to add just a couple of little pieces. So first, when we do our two sets of parentheses, we're going to put an AX at the beginning. Now, I know that that is too much, right? Because when I FOIL that, I would get A squared X squared, not A times X squared. And that's okay, because we're going to take the extra out in a minute. Our signs work the same way. So the sign in the first set, is the same as the first sign in the problem. The sign in the first set times the sign in the second set have to equal the last sign. So that didn't change. The second difference, I guess, because the first difference was putting AX in each set. The second difference is, instead of just looking for numbers that will multiply to give us C, we're going to multiply A times C. So I'm going to be looking for two numbers that will multiply to give me that product and use the last sign to give me the linear coefficient. Just like before, we will put the bigger number in the first set and the smaller number in the second set. The last step here is, remember, we put in too much. So now what we're going to do is look in each set for a common factor. If there's a common factor in either set or both sets, we will take it out. And not only do we take it out, we just throw it away. We don't have to bring it out front or do anything with it because we put in too much at the beginning, okay? So this is kind of an example of something that maybe isn't super mathy, but works every single time. Okay, so let's try it. So looking at this first one, that's the 5z squared, I'm going to start with two sets of parentheses with a 5z in each set. So again, I know that's too much because I know if I multiply that together, I'm going to get 25z squared, right? But I'm going to take the extra out in just a minute. So our signs work the same as before. The sign in the first set is positive, and the sign in the second set is positive. Now we're looking at A times C. 5 times 2 is 10. So I'm looking for two numbers that will multiply to give me 10 and add to give me 11. So that's 10 and 1, and our 10 goes in the first set. Now, when I look at that first set, I see there is a common 5, right? The second set does not have a common factor, but the first set does. So I'm just going to factor that 5 out. I'm going to divide it out. So I'm going to have z plus 2 times 5z plus 1. And again, I could just take that out because I put too much in at the beginning. Typically, you'll only have a common factor in one set, but you could have a common factor in both sets, and you would just take both out. Let's do a couple more before we throw trig at it. So 2 sets of parentheses with a 7z in each set. The sign in the first set is negative. What's the sign in the second set? Negative, because negative times negative is positive. Now I do the A times C. 7 times 6 is 42. I'm looking for two numbers that will multiply to give me 42 and add to give me 23. 21 and 2. And I see that that first set has a common 7. So again, since I put in too much at the beginning, I can just take that common factor out. And I'll have z minus 3 times 7z minus 2. Again, there's lots of other ways of factoring with a lead coefficient where you're trying to match stuff up and worrying about the signs. To me, this is the simplest way, takes up the least amount of space, which I also like, right? Let's do one or two more, and then we'll throw some trig at it. So here, 2 sets of parentheses with a 3x in each set. Sign in the first set is negative. Sign in the second set is negative. 3 times 8 is 24. So I'm looking for two numbers that will multiply to give me 24 and add to give me 14. 12 and 2. 12 goes in the first set. Even though the signs are the same there in those parentheses, it's just good practice to always put the bigger number in the first set so you don't make a mistake later. First set has a common 3, which we can just take out and throw away. So x minus 4, 3x minus 2. Let's do two more, and then we'll move on. So 2 sets of parentheses with a 7y in each set. Sign in the first set is positive. Sign in the second set is positive. 7 times 10 is 70. And I'm looking for two numbers that will multiply to give me 70 and add to give me 19. Well, let's see. 7 times 10 won't do it, right? 5 and what? 5 and 4? No, 5 and 14, right? So there it is. So we put the 14 in the first set. And then we have a common 7 in the first set. If you get there and you don't have a common factor anywhere, you messed up, right? Because you're going to have something that comes out. So y plus 2, 7y plus 5. Last one of these, 2 sets of parentheses with a 2y in each set. Sign in the first set is negative. Sign in the second set is positive, right? Because negative times positive is negative. 2 times 21 is 42. So I'm looking for two numbers that will multiply to give me 42 and subtract to give me 11. Well, 42 is 2 times 21. That's not it, right? 3 times 14. There it is. So we'll put the 14 in the first set. And the first set has a common 2. So we have y minus 7, 2y plus 3. Okay, so that's just kind of a little review, right?